In this lecture, we will discuss about Poisson distribution. So Poisson distribution. So this is also a discrete probability distribution. Also a discrete probability distribution. Distribution. And this is extended form of binomial distribution. Extended form of binomial distribution. So we know about binomial distribution when we have fixed number of trials to get the successes in fixed number of trials. So now we know that the binomial distribution probability P of x is equal to x successes. We write down as NCx, P raised to the power x and Q raised to the power n minus x. So binomial distribution having two parameters that are n and p. Number of trials n and p with the probability of success. So that means here we have the values of x equal to 0, 1, 2, 3 and so on. So this is the binomial distribution. Now we take one example. So when we take one example, so if we put the value of n is equal to 4 and p probability p which is equal to 1 by 2. So we are going to calculate the find probability of three successes. Probability of three successes. So now we write down the binomial distribution. So by solving this problem by using binomial, so for calculating probability of three successes, we put x is equal to 3. So this gives us NCx, so 4C3 P 1 by 2 raised to the power x power 3 and Q. So Q we write down as 1 minus P. So this also gives us 1 minus 1 by 2 is equal to 1 by 2. So 1 by 2 raised to the power 4 minus 3. Now we write down this as 4C3 and the power when base is same. So power, we add the power. So power gives us 4. So what is the value of 4C3? So we can calculate as factorial 4 upon factorial 3 into 4 minus 3 factorial into 1 by 2 raised to the power 4. So factorial 4 is 24. 24 upon factorial 3 is 6. And this is 4 minus 3. 1 factorial is 1. So 1 by 2 raised to the power 4. So this gives us 2 2 ja 4 2 ja 8 2 ja 16. So 6 4 ja 24. So this gives us 4 by 16. We can write down this as 1 by 4. So without calculator, we are able to solve such type of problems. So in this, you understand that we apply directly the binomial distribution and we solve the probability of three successes. Now, when we extend this n and p, that means we can take the other values of n and p. So then the binomial distribution is capable to solve easily or not. So now we move to the next example. So if we consider n is equal to 1000. So n we consider as 1000 and the probability p we consider as 1 upon 100. So we calculate then we calculate the probability of three successes. We calculate the probability of three successes. So how? to calculate this, so we calculate the probability of three successes. Calculate the probability of three successes. Same, in previous part we have solved probability of three successes. Here also we solve the probability of three successes, but we have two changes. We increase the value of n, number of trials we increases, and probability we decreases. Okay, so you know, when we increase the number of trials, so obviously when we have large number of trials, the probability of success is obviously low. So now when we apply the binomial distribution, so we calculate the probability of three successes. So NCX, so 1000, N is 1000, CX, X means three successes. So NCX, now P, so probability P, which is 1 upon 100, 100 raised to the power X, into Q. So Q also we can write down as 1 minus 1 upon 100 or 99 upon 100. We can write down that. So N minus X. So now when we simplify this, that means we can write down this as 1000 C3, 1 upon 100 raised to the power 3, or this can be written as 99 upon 100 raised to the power 997. अब देखिए आप कि जब पहला जो पार्ट था जहां पर हमारा एन स्मॉल था और पी लार्ज था, प्रोबेबिलिटी ऑफ सक्सेस इज लार्ज और एन नंबर ऑफ ट्रायल्स आर स्मॉल, सो देन हमने कितना इजीली कैलकुलेट कर लिया उसको. बट यहाँ पर हम देख रहे हैं कि जब हमारा एन लार्ज हो गया, एन लार्ज हो गया मीन्स एन 1000 हो गया, दिस ये आपको बढ़ के 10,000 भी हो सकता है, 20,000 भी हो सकता है. और प्रोबेबिलिटी सक्सेस में भी लो, मतलब ये आपका 1/100 है, 1/1 lakhs भी हो सकता है, 1/10,000 हो सकता है, तो वेरी नेग्लिजिबल प्रोबेबिलिटी के मे बी. ओके, सो so now it is very complicated. Okay, so this is very difficult to solve. So it is not easy to solve. So we can write down here. It is very difficult. It is very difficult to calculate the probability of three successes. Probability of three successes. So in this case, we can write down in this case, when n is large, when n is large and p is small, and p is small. So when n is large, p is small. So then we introduce new parameter. So that means that parameter we can take as product of n into p gives us lambda. So which is a constant, which is a constant. So then we write down the binomial distribution. Then the binomial distribution tends to Poisson distribution. Poisson distribution with single parameter tends to Poisson distribution with probability mass function. In short, we write down as PMF, probability mass function. P of x is equal to x successes. We write down as e raised to the power minus lambda, lambda raised to the power x upon factorial x. Okay, so this distribution, that means binomial tends to Poisson distribution where n is large and p is small. So you remember when we have very large value of n, so n is large and p is small. So we use the Poisson distribution. So here we have a np is equal to lambda. So the limiting form of the, so the limiting form we can write down as the limiting form. This is the limiting form. So the limiting form of binomial distribution is known as Poisson distribution. Poisson distribution, known as the Poisson distribution. So होप यू अंडरस्टैंड, आपने समझा होगा कि किस तरीके से हम बाइनोमियल का एक्सटेंडेड फॉर्म पॉइसन डिस्ट्रीब्यूशन में चेंज करते हैं. नाउ वी राइट डाउन द प्रोबेबिलिटी मास फंक्शन. अब नए सिरे से पॉइसन डिस्ट्रीब्यूशन को एक्सप्लेन करना. सो वी राइट डाउन द डेफिनेशन. ए रैंडम वेरिएबल, ए रैंडम वेरिएबल, और रैंडम वेरिएबल भी कैसा होगा? डिस्क्रीट. रैंडम वेरिएबल एक्स टेकिंग द वैल्यूज, टेकिंग द वैल्यूज 0, 1, 2, 3 and so on is said to have a Poisson distribution, Poisson distribution with parameter lambda. So here only one parameter, single parameter in Poisson distribution, which is lambda, or this lambda is greater than 0, means always positive. So Poisson having one parameter. So the probability of x successes, probability of x successes, we can write down as p of x equal to x successes can be written as e raised to the power minus lambda, lambda raised to the power x into upon factorial x. So we can write down as x is equal to 0, 1, 2, 3. 0 represent the no success. That means x equal to 0, then 1 success, 2 success, 3 success. Okay. Now, so this is the Poisson distribution probability mass function. So you remember this one because this help us to solve the problem related to Poisson distribution. So this is the probability mass function PMF of Poisson distribution. Now we know that the sum of all the probabilities, हम जानते हैं कि जो sum होगा probabilities का वो क्या होता है? x equal to 0 to infinity into px. The sum of all the probabilities always क्या होता है? Equal to 1. Okay, sum of all pi is always equal to 1. So how to prove that? So we can prove that by using the probability mass function of Poisson distribution. So we write down as x equal to 0 to infinity, and PMF of this e raised to the power minus lambda into lambda raised to the power x upon factorial x. So this we can write down this as, so when we open the summation, so when we put the x equal to 0, so this gives us e raised to the power minus lambda into lambda raised to the power 0 upon 0 factorial plus e raised to the power minus lambda, lambda raised to the power 1 upon 1 factorial plus e raised to the power minus lambda, lambda raised to the power 2 upon 2 factorial plus e raised to the power minus lambda, lambda raised to the power 3 upon 3 factorial plus e raised to the power minus lambda, lambda raised to the power 4 upon 4 factorial plus and so on. Now, when we solve this, so we can take e raised to the power minus lambda as common. तो सभी से e raised to the power minus lambda कॉमन ले लिया. अब lambda raised to the power, lambda raised to the power 0 क्या होगी? 1, और फैक्टोरियल 0 भी क्या होता है? 1. सो दिस गिव्स अस 1. पहला टर्म 1 आ जाएगा प्लस सेकंड होगा लैम्डा, लैम्डा अपॉन फैक्टोरियल 1. दूसरा टर्म क्या होगा? लैम्डा स्क्वायर अपॉन फैक्टोरियल 2. नेक्स्ट होगा लैम्डा क्यू अपॉन फैक्टोरियल 3. नेक्स्ट होगा लैम्डा रेज टू द पावर 4 अपॉन फैक्टोरियल 4 प्लस एंड सो ऑन. नाउ अब एक्सपेंशंस, यू नो द एक्सपेंशंस. अब हमें एक्सपेंशन पता होनी चाहिए. एक्सपेंशंस, अब एक्सपेंशन की बात करते हैं तो ई रेज टू द पावर एक्स का एक्सपेंशन क्या होता है? 1 प्लस एक्स स्क्वायर अपॉन फैक्टोरियल 2 प्लस एक्स क्यू अपॉन फैक्टोरियल 3 प्लस एंड सो ऑन. सो दिस इज द एक्सपेंशन ऑफ ई रेज टू द पावर लेमडा, क्योंकि एक्स किससे रिप्लेस हो रहा है? लेमडा से. सो दिस कैन बी रिटन एज ई रेज टू द पावर माइनस लेमडा इनटू ई रेज टू द पावर लेमडा. जब दोनों का बेस सेम है तो पावर क्या होती है? ऐड हो जाती है. तो माइनस लेमडा प्लस लेमडा, तो ये क्या हो जाएगा, ई रेज टू द पावर जीरो, और ई रेज टू द पावर जीरो क्या होगा, वन, समथिंग रेज टू द पावर जीरो, वन. So e raised to the power 0 is 1. So now we have proved the sum of all the probabilities means summation of x equal to 0 to infinities p of x is equal to 1. Now, after understanding the sum of all the probabilities is equal to 1, so we know the uh, uses of Poisson distribution, where we use this Poisson distribution. So we write down as Poisson distribution has very wide applications. Has very wide applications. So where we use this distribution, because this have very real life uses. So we can obtain the behavior of the number of accidents on road. अब हमें जैसे डाटा पता करना है कि कोई पर्टिकुलर हाईवे है, उस हाईवे पे डे वाइज कितने एक्सीडेंट्स हो रहे हैं, मंथली कितने एक्सीडेंट्स हो रहे हैं, ईयरली कितने एक्सीडेंट्स हुए. तो वी कैन चेक फॉर पर्टिकुलर ऑन हाईवे और पर्टिकुलर स्टेट हाईवेज डाटा. So we can calculate by using this Poisson distribution. Second, we calculate the number of defective items, number of defective items in pointed surface of unit area. Defective items may be in the form of a company produce some type of electric bulbs, some type of bulbs. So that means some bulb may be in defective. So we can check defective items. Some uh, company may produce the bolt, fuses, so etc. So we can solve the number of fuses, the probability of number of bulbs. Third is number of telephone calls. Number of telephone calls received at particular switch. At the particular switch. Particular switch in the exchange. Particular switchboard in exchange. ओके. आपने पुरानी एक्सचेंज देखी होंगी, वहां पर स्विचेस लगे हुए थे एरिया वाइज. So we can obtain the number of telephone call received by a particular switch board in exchange. Next is the number of deaths. The number of deaths due to a specific disease. So due to specific disease, that means cause may be COVID-19, some specific causes are there, tuberculosis, cancer, etc. So these are the very wide applications for Poisson distribution. Now we move to the next part. This is the Poisson frequency distribution. Poisson frequency distribution. So basically in this distribution, some frequency, number of repeated trials are given. Okay. So we write down as n trials. N trials for an experiment. Constitute for an experiment. And That experiment repeated n times, capital N times. That experiment repeated n times. So then the expected Poisson frequency distribution, Poisson frequency distribution, we write down as fx, denoted by fx equal to n into px. So this can be written as n into px. Px means e raised to the power minus lambda, lambda raised to the power x upon factorial x. So where x is equal to 0, 1, 2, 3, and so on. So this is the Poisson frequency distribution. So that means n trials constitute for an experiment, or that experiment repeated n times. So we use the Poisson frequency distribution in such cases. So now we write down the properties. So basic thing we have to remember, that is properties. So properties of Poisson distribution. So where we have a 4 to 5 properties, basic properties we have to remember. So we write down this as this distribution has only one parameter, has only one parameter, that is lambda. So we can write down that when n and p is known, so then we calculate lambda with this formula equal to np. Now the mean of Poisson distribution is lambda. The mean of this distribution is lambda, and also variance. We can write down this third is the variance of Poisson distribution is lambda. So mean and variance of this distribution are same. You know what is the mean and variance of binomial? The binomial mean is NP and variance is NPQ. But this distribution having the mean and variance are same. So fourth or important thing we write down is with the following conditions. Binomial distribution tends to Poisson distribution when p is small, n is large. So we remember these things. So after understanding about the probability mass function of Poisson distribution and Poisson frequency distribution and its properties, we move to the questions. So we start the basic questions related to Poisson distribution. So first question we will take as, if a random variable x follows the Poisson distribution such that probability P of x equal to 1 is equal to P of x equal to 2. So find mean of the distribution, mean of the distribution means we calculate the lambda. Second, calculate probability of x equal to 0 after finding the mean. So now we do the solution of this. So for solution, given condition is this. So we can write down as, so given probability of x is equal to 1 is equal to probability of x equal to 2. So this is our equation number 1. And this is given. Now we shall move to the Poisson distribution. So we write down as, we know that the Poisson distribution, because this follow the Poisson distribution, so we take the probability mass function of Poisson distribution. So probability of x equal to x successes, this can be written as e raised to the power minus lambda into lambda raised to the power x upon factorial x, where x like 0, 1, 2, 3, and so on. Now we put the value of x. So here in LHS x equal to 1, in RHS x equal to 2. So now from 1 directly we write down from equation number 1. So probability of x equal to 1. So when we put x equal to 1, so this can be written as lambda raised to the power 1 upon 1 factorial. This equal to 2. So when we put x equal to 2, so this can be written as lambda raised to the power 2 upon 2 factorial. Now, so this e raised to the power minus lambda, 2 e raised to the power minus lambda cancelled. So lambda upon factorial 1 is 1 is equal to lambda square upon factorial 2 is 2. So lambda to lambda cancelled. So here 1 is equal to lambda upon 2. So this implies that lambda is equal to 2. Cross multiply कर देंगे तो lambda की वैल्यू क्या आ जाएगी 2. So lambda means mean. So mean of this distribution is 2. अब और हमारा फर्स्ट पार्ट सॉल्व हो जाएगा. So mean of the distribution is 2. तो lambda इक्वल टू 2. अब सेकंड पार्ट सॉल्व करना है. सेकंड पार्ट उसमें क्या बोला है कि सेकंड पार्ट में प्रोबेबिलिटी ऑफ एक्स इक्वल टू 0 कैलकुलेट करो. सो प्रोबेबिलिटी ऑफ एक्स इक्वल टू 0 कैलकुलेट करेंगे तो पुट कर देंगे पोइसन डिस्ट्रीब्यूशन में. तो क्या हो जाएगा, ई रेज टू द पावर माइनस लेमडा, लेमडा रेज टू द पावर 0 अपॉन 0 फैक्टोरियल. तो ये क्या आ जाएगा, ई रेज टू द पावर माइनस लेमडा और लेमडा रेज टू द पावर 0 इज 1 अपॉन फैक्टोरियल 0 इज 1. सो ये क्या हो जाएगा, ई रेज टू द पावर माइनस लेमडा, और लेमडा हमने क्या कैलकुलेट किया है, -2. So e raised to the power -2 is the answer. You can write down the 1 upon e raised to the power 2. Okay, so you can solve by using calculator. What is the value of e? So the value of e is 2.71. So you can solve. So you can write down the value of 1 upon 2.71 to the whole square. So you can simplify by calculator. Now we move to the next question. So next question is, find the probability that at most 5 defective fuses will be found in a box of 200 fuses. In a box of 200 fuses, if experience shows that 2% of such fuses are defective. 2% of such fuses are defective. And the value of e raised to the power minus 4 is 0.0183. सो पहले तो हमने क्या अंडरस्टैंड किया कि जो चार कंडीशन दे रखी थी, नहीं तो बेसिक वेयर वी यूज द पॉइसन डिस्ट्रीब्यूशन, अगर कहीं पर भी डिफेक्टिव आइटम्स हैं, so we can apply the Poisson distribution, defective fuses. Okay, so defective items, or we can say that the number of deaths, number of road accidents occur on particular highway, number of uh, fuses, number of errors. So we can apply the Poisson distribution. So here we have the probability, experience. ये क्या लिखा हुआ है? If experience shows that, एक्सपीरियंस कहता है कि जो बॉक्स है उसमें 2% तो फ्यूज बल्ब निकलते ही निकलते हैं, दैट मीन्स फ्यूजेस डिफेक्टिव निकलते ही निकलते हैं. सो 2% फ्यूजेस आर डिफेक्टिव, सो दिस इज अवर प्रोबेबिलिटी. सो व्हेन वी राइट डाउन दिस, सो प्रोबेबिलिटी ऑफ फ्यूजेस बीइंग डिफेक्टिव. अब जो प्रोबेबिलिटी ऑफ फ्यूजेस बीइंग डिफेक्टिव, इसको हम क्या अज्यूम करके चले कि दिस इज अवर सक्सेस. Success. So we are going to calculate the probability of success. Means fuses are defective. That will be the 2%. That is the 2%. So we can write down a 2 upon 100. So 2 upon 100 can be written as 0.02. So this is the probability of defective fuses. Now, what is the n? N is equal to 200. मतलब जो बॉक्स है उस बॉक्स में कितने फ्यूजेस हैं? 200 फ्यूजेस हैं. So n equal to 200. Now, when we have n and p, so we can calculate the parameter lambda. So lambda parameter can be calculated as np. So n equal to 200 into 0.02. So this gives us 4. This gives us 4. So lambda is equal to 4. Now, by Poisson distribution, so we write down the Poisson distribution. अब यहां से भी आप आइडेंटिफाई कर सकते हो कि हमें क्वेश्चन क्यों लगाना पड़ेगा, क्योंकि हमारा एन लार्ज हो गया, एन 200 हो गया, और पी हमारी स्मॉल है, 2/100 है. दैट्स वाई वी यूज द Poisson distribution. So by Poisson distribution we write down the probability of x successes can be written as e raised to the power minus lambda into lambda raised to the power x upon factorial x. So probability of x at most, there are two words, one we use at most, second we use at least, or third word we use the exactly. So at most means we have to calculate the probability of at most 5 defectives. So this term, at most 5 defectives, so we can take as less than or equal to 5. So x less than equal to 5, at most 5 defectives. So we write down as, so this can be written as probability of at most 5 defectives. So at most 5 defectives. So we calculate for less than equal to 5. So this can be written as this equal to, we can write down as probability of x equal to 0 plus probability of x equal to 1. कहाँ तक लिखना होगा? 5 तक. x equal to 2 plus probability of x equal to 3 and plus probability of x equal to 4 and plus probability of x equal to 5. So this we can write down as, सो प्रोबेबिलिटी ऑफ एक्स इक्वल टू 0. अब इसमें हमें क्या कर देंगे? लेमडा की वैल्यू पुट कर देंगे. तो लेमडा की वैल्यू क्या हो जाएगी? ई रेज टू द पावर माइनस 4 इंटू 4 रेज टू द पावर एक्स अपॉन फैक्टोरियल एक्स. ये हमारा क्वेश्चन डिस्ट्रीब्यूशन बन जाएगा, वेयर वी पुट एक्स इक्वल टू 0 1 2 3. अब यहाँ पर क्या है, ये वैल्यूज पुट कर देंगे. तो एक्स की जगह 0 पुट करेंगे, तो दिस गिव्स अस ई रेज टू द पावर माइनस 4 इंटू 4 raised to the power 0 upon 0 factorial plus e raised to the power minus 4 into 4 raised to the power 1 upon 1 factorial plus e raised to the power minus 4 into 4 raised to the power 2 upon 2 factorial plus e raised to the power minus 4 into 4 raised to the power 3 upon 3 factorial plus e raised to the power minus 4 into 4 raised to the power 4 upon 4 factorial plus e raised to the power minus 4 4 raised to the power 5 upon 5 factorial. ओके, सो डायरेक्ट वैल्यू पुट कर दी हमने, एक्स की जगह 0 1 2 3 4 5 पुट कर दिया। अब सॉल्व करेंगे तो ई रेज टू द पावर माइनस 4 तो कॉमन आ जाएगा सभी से, so we can take e raised to the power minus 4 as common. So फर्स्ट टर्म क्या होगा, 4 रेज टू पावर 0 1 हो जाएगा, 0 फैक्टोरियल 1 हो जाएगा, तो 1/1 1 हो जाएगा, प्लस यहाँ से कितना आ जाएगा 4 आ जाएगा, 4 अपॉन फैक्टोरियल 1 4 हो जाएगा, प्लस यहाँ से कितना आ जाएगा 4 4 जा 16, 16 और फैक्टोरियल 2 की वैल्यू क्या होगी 2 होगी, इधर से क्या आ जाएगा 4 4 जा 16, 16 4 जा 64, 64 अपॉन फैक्टोरियल 3 कितना हो जाएगा 6, प्लस 4 रेज टू द पावर 4, तो 64 4 जा 256, तो 256 अपॉन 24 और प्लस 4 रेज टू द पावर 5 कितना जा 256 4 जा 1024, 1024 अपॉन 120 फैक्टोरियल 5, so 120. So you can solve this. So e raised to the power minus 4 is already given. This is 0.0183 into 1 plus 4 plus 8 plus 32 upon 3 plus you can simplify this. So 4 64 upon 6. So that means this is also 32 upon 3. And also you can simplify. So 4 2 is 8 or 4 30. Okay, you simplify this. So the answer will be approximately 0.785. 0.785. Now we take one more question related to that. After correcting 50 pages of the proofread of a book, the proofreader find that there are on an average there are on an average 2 errors per 5 pages. 2 errors per 5 pages. So how many pages would one expect to find x equal to 0 1 2 3 4 errors in 1000 pages of the first print of the book? So here the value of e raised to the power minus zero point 0.4 is given 0.6703. Okay, so we already understand or remember that when we are talking about the errors, defective items, so we apply the Poisson distribution. So here also we apply the Poisson distribution because we are going to calculate the errors. Now, so when we do the solution of this, so here we calculate the number of errors. So there are 2 errors per 5 pages. So this is on an average. Average means mean. So that means we find the average number of errors. So we find the average number of errors. Average number of errors So that can be denoted by lambda, or lambda is equal to np. So lambda is equal to np, or that will be 2 upon 5. So this will be zero point 0.4. So directly given 2 error per 5 pages. So 2 by 5. So that means average of errors. So lambda equal to zero point 0.4. So lambda equal to zero point 0.4. So now the probability of x errors can be obtained by using Poisson distribution. We use the Poisson distribution. So we have the PMF of Poisson distribution is equal to e raised to the power minus lambda into lambda raised to the power x upon factorial x, where x equal to 0, 1, 2, 3, and so on. So now number of pages. How many pages are given? 1000 pages. So capital N is 1000 pages. So N is equal to 1000 number of pages. So the expected number of pages, we write down the expected number of pages with x errors is fx equal to n into px. Fx equal to n into px. So binomial, Poisson frequency distribution. So we can write down this as, so 1000 into e raised to the power minus lambda, lambda raised to the power x upon factorial x. So when we put the value of lambda, so this can be written as 1000 into e raised to the power lambda means zero point 0.4 into zero point 0.4 raised to the power x upon factorial x. Now we start finding the errors. So how many errors we will find for x equal to 0, 1, 2, 3, and 4. So now we shall find for number of pages for x equal to 0 errors. So how many pages are there who have 0 errors? So that means we can calculate the value of f naught. F naught, so we can write down as 1000 into e raised to the power zero point 0.4 into zero point 0.4 raised to the power 0 upon 0 factorial. So this can be written as 1000 into e raised to the power minus zero point 0.4. So what is the value of zero point 0.4 minus zero point 0.4? So this value is given as 0.6703. So this value is given in the question directly, 0.6703. So now when we multiply these two, so this gives us 670.3. तो इसको किसके इक्विवेलेंट कर लेंगे? 670 के, क्यों 0.3 में फ्रैक्शन में तो पेज होगा नहीं. तो दैट मीन्स 670 पेजेस आर देयर हु हैव जीरो एरर. बुक में टोटल कितने पेज है? 1000. 1000 में से 670 पेजेस ऐसे हो गए जिसमें क्या आ रहा है हमारा? कोई भी एरर नहीं आ रहा है, जीरो एरर आ रहा है. अब कैलकुलेट करना है किसके लिए कि नंबर ऑफ पेजेस विच हैविंग वन एरर. नंबर ऑफ पेजेस बताइए जिसमें एक एरर होगा. सो वी कैन कैलकुलेट फॉर f1. तो f1 इक्वल टू 1000 इंटू ई रेज टू द पावर माइनस 0.4 इंटू 0.4 रेज टू द पावर 1 अपॉन फैक्टोरियल 1. सो दिस कैन बी रिटन एज 1000 इंटू ई रेज टू द पावर माइनस 0.4 की वैल्यू वही 6703, और इंटू क्या आ जाएगा? 0.4 आ जाएगा. सो ये कितना हो गया? 670.3 into 0.4. So when we multiply this, so this gives us approximately 268 something. So 268.1 something. So we can take as equivalently 268. So 268 pages are there who have only one error. Now we calculate for two errors. So x equal to two errors. So x equal to two errors, we will calculate for f2. So 1000 into e raised to the power minus zero point 0.4, zero point 0.4 into zero point 0.4 raised to the power 2 upon 2 factorial. So this can be written as 1000 into, इसकी वैल्यू क्या है? 0.6703, और ये कितना हो गया? 0.16 हो गया, और अपॉन में फैक्टोरियल 2 की वैल्यू 2 आ गई. तो देन वी सिंप्लीफाई दिस. तो दिस गिव्स अस अप्रोक्सीमेटली 53.62. तो इसको इक्विवेलेंट कर लेंगे हम किसके, 54 के. ओके. 0.5 के बाद डेसिमल प्लेस पे आगे ले जाएंगे, तो 54. अब नेक्स्ट वी कैलकुलेट फॉर 3 errors. x इक्वल टू 3 errors. So how many pages are there who have 3 errors? So f3 equal to 1000 into e raised to the power minus zero point 0.4 into 0.4 raised to the power 3 upon factorial 3. तो यहाँ से क्या आ जाएगा, 1000 into 0.6703, और ये हो जाएगा 0.4 raised to the power 3 upon 6. So when we solve this, so this gives us approximately 7.14. So which is equivalent to 7 errors. Which is equivalent to 7 errors. So now last we calculate for 4 errors. So we calculate for 4 errors. So x4 equal to 1000 into e raised to the power minus zero point 0.4 into 0.4 raised to the power 4 upon factorial 4. So this can be written as 0.6703 into zero point 0.4 raised to the power 4 upon 24. So this gives us approximately 0.714. So which is equivalent to 1. So when we do the sum of all errors is also equal to 1000. Okay.